So we're on lesson 5. The Pythagorean theorem. Hi there. You over there is good. Today's date's the 21st of March. Now, what most likely is going to happen, this is a really important concept in geometry, but it's also can have a lot of fun to it. So I've got a couple of ideas I need to run past Mr. Johnson, but my thought is that Thursday, I'm going to give you guys an art project dealing with Pythagorean theorem, and it'll be due Tuesday after we come back from break. So you'll have plenty of time that you can choose to do it before break, during break, after break. Okay, so, but it'll be a fun idea. I just have to figure out which one he wants to do. Okay, so Pythagorean theorem. Anyone know anything about Pythagorean theorem? Okay. It deals with that type of triangle. What kind of triangle is that? Right. Okay, so this only applies to right triangles. We're going to identify the parts of the right triangle because we're going to use those words to help us when we're doing the Pythagorean theorem. Does anyone know what we call the sides that form the right angle? I'll give you a hint. You've got two of them on your body that help you
Arms.
stand.
Legs.
Okay, so these are called legs. In a right triangle, the longest side has a special name. Okay, and he's always the side opposite the right angle. It starts somewhat similarly to when you're in a science class and you have to come up with what is it that you're going to try to prove. What do you call that, what you're trying to prove?
Theory.
Starts with the letter H.
Hypothesis.
Hypothesis. So this is close to that. It's called a hypotenuse. Okay. Now, I'm going to, in addition to this, label my legs with some variables. So we'll call the one leg A, and we'll call one leg B. And we're going to call the hypotenuse C. Okay? And in our particular problem, I'm going to actually give some numbers, just so we can see what happens. So I'm going to say that leg A has a value of 6. Leg B has a value of 8. And I'm going to tell you that the hypotenuse has a value of 10. Okay? Now, I'm going to take those three numbers, 6, 8, 10, and mathematically there's a way to make the 6 and the 8 equal to the 10. Any thoughts? Can I just do one simple operation and get them equal to 10? No, so I can't just add, and I can't just subtract, and I can't just multiply, and I can't just divide. So that's not going to work. So I'm going to have to do two things. So what's something else we could try with those numbers? Six divided by 8 isn't going to give me 10. You can't add and subtract two numbers. You can only get one operation between them. So like I said, that one operation is not going to solve it. So we're going to have to try something more. I can't alter those numbers in terms of multiplying each number by something or dividing each number by something. The 6 has to be a 6. The 8 has to be an 8. The 10 has to be a 10. So what could I try? Okay. Let's do it this way. I'm going to erase these words and these and these. And we said this one had, it was a 8, and if I extended the sides to make a square, I would have an 8 by 8 square. So what I'm going to do is create eight by 8s. Okay, and I'm going to color this. Let's make it the original color. So all of these are going to be this color. You can do a symbol in there if you want to. You can do like a diagonal. You could do a plus. You could do an X. Okay, and then off the other side, we said this measured 6, so we'll make this a 6 by 6 square. And I know that doesn't look very squarey, but it's the best I can do. And I'm going to darken these in. Okay, so let's make an accounting. How many of the light purple squares did I end up with? How many? I had 64 here. And how many of the darker purple squares did I end up with? How many? 36. So now I'm going to do the same thing to this guy. Oops. And he's supposed to be at 10 by 10, right? Oops, that's going to be too big. Oh, no, that's okay. So now I've got 10 by 10. Or how many boxes would that be? How many boxes have I just created? 100 boxes, right? So here's what's interesting. Make sure those all go across. So what I'm going to do is take my light purple 64 and put them in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 1, 2, 3, 4. Now I'm going to take the darker purple ones, and I've got 36 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So all the little boxes from the legs, both legs together ended up being the same as what the big box would give me. So what did I do to the 6 to get the 36? So I squared it. And then what did I do to the 8 to make it 64? I multiplied by itself. How many squares did I end up with the big box, did we say? There was 100 boxes here. And what do I do to 10 to make it 100? I square it. Now, what did I do to the 36 boxes and the 64 boxes to make it the 100 boxes? What math did I do? Cameron? I added them. That is basically what the Pythagorean theorem ends up telling us. Now, it's called the Pythagorean theorem because a guy named Pythagoras, back in the days of the Greeks, discovered this relationship. And it holds true for all right triangles. Now, we're lucky that these numbers work out so neatly. Okay? Not all numbers work out neatly, and you can get decimal numbers, and you can get numbers left with radical signs, and that's okay. But this is how we can figure this out. So, let's write it down in words. The Pythagorean theorem. I'm going to do it on the next page. And we'll highlight that. So the Pythagorean theorem says, and again, the key first words, it only works for right triangles. So in a right triangle, the sum of the squares of the legs, I should say lengths of the legs. Legs are objects. Lengths of the legs is equal to the square of the hypotenuse, or the length of the hypotenuse. So, let me just draw my picture real quickly again. We've got our little right triangle. I know because of the little right angle in the corner. And then I'm going to label the three sides. The two legs are A and B, and it doesn't matter who's A and who's B. As long as they're the two sides that make the right angle, that's all that matters. And we get C as the hypotenuse. And then this is what the theorem says. The sum of the squares of the legs is equal to the square of the length of the hypotenuse. So we get A squared plus B squared equals C squared. So we use the Pythagorean theorem to help us when we know two of the three sides of a right triangle, and we want to figure out what the third one is. So we are going to use some squaring, and we may end up doing some square rooting if we're trying to figure out a value. So let's go ahead and do a couple practice problems of this. So first one, the directions are going to ask us to find or write an equation to find the missing part of the right triangle then find the missing part, or the missing length. Now, if it doesn't work out evenly, we're going to have to round to the nearest tenth if necessary. So our first problem, we've got 9 inches, 12 inches, and C. So we know that we've got a squared plus b squared equals c squared. So I'm going to plug in numbers, and again, it doesn't matter who's a and who's b. So I'm going to substitute in 9 for a and 12 for b. And remember, we talked about in the very beginning of the year how important it was for you guys to memorize your perfect squares from 0 to 20 squared. Well, now it's going to come into play. Okay? So what's 9 squared?
81.
81. And what's 12 squared? 144. And that equals c squared. So then we're going to add them together. And we get 225 equals c squared. So I'm going to rewrite it this way with a symmetric property and have the c squared in front. Now, I'm not solving for something squared. I'm solving for a length of something. So I just want to know what c is. So how do I get c squared to become c? What math am I allowed to do to get something squared just to become something normal? Nancy? I can't divide it by 2. That's going to give me c squared divided by 2. So what I need to think of, what's the opposite of squaring something? Now, unsquaring is not the word. I heard that. It's not unsquaring. Say it again, Simon?
Square root.
We're going to take a square root. So how it works is whatever I do to one side, I must do to the other side. So the square root of something squared just gives me the base. When that index 2 and that exponent 2 are the same, the base c comes out. Now here comes the trick part. Again, this is off that list I asked you guys to memorize. What times itself gives me 225? 225 times itself doesn't give me 225. 1 times itself gives me 1. Well, I know it's got to be over 12 because 12 is 144. 12 squared is 144.
15.
Okay, and it is actually 15. Now, when I take the square root, I actually get 2 answers, right? I get a positive 15 or a negative 15. However, one of those answers would not make sense in this situation because I'm looking for the length of something. So what answer can I eliminate? I can eliminate the negative. So when it comes to Pythagorean theorem, we're only going to be looking for the positive answer because that's the only one that's going to make sense for us. Now, our answer's not complete because we're going to drop off the c and we're going to add a label. So what label are we going to add to this? Inches. So we could say in words, c represents the hypotenuse. And we'd say the hypotenuse is 15 inches long. Okay? So now what we're going to do is we're going to switch it up. And it's not going to be C that's missing. It's going to be either A or B. So how is that going to change what we end up doing? So in this example, we're going to do this. And we're going to get 8 meters, B meters. Let's change that a little bit. And 24 meters. So again, we're going to start with a squared plus b squared equals c squared. So the a is the 8 because it's one of the legs. B stays B because we don't know what it is. And the hypotenuse, the one opposite the right angle, is going to get squared. So we start by doing whatever math that we can do. Well, 8 squared is going to give me 64. I cannot take B and square it because I don't know what B is. And off to the side, I can figure out what 24 squared is. So I get 16, 8 and 1 is 9. Put in a placeholder. I get an 8. And 2 times 2 is 4. and I get 576. All right, now what would I do? Remember, I'm trying to figure out what b squared is. Savannah? Yeah, I'm going to have to subtract 64 from both sides so that I can isolate b squared. So I subtract that, and I get b squared is equal to 512. All right, and now we're ready that we've got our square term by itself. We're ready to take the square root of both sides. But here's a problem. 512 isn't a perfect square. I know that because it's pretty close to 576, which was 24 squared. And it's smaller than that. So I'm going to have to do estimation, which again we did at the beginning of the year. So right now, this is where I'm at. B is equal to the square root of 512. So what I'm going to do is try to figure out what two numbers it falls between. So I'm going to check 23 and see what 23 squared gives me. So this gives me 9, 6, placeholder, 6, 4, and I get a 9 to 529. Okay, that's pretty close. Let's try 22. I get 4, 4, placeholder, 4, 4, and I get 484. So this is going to fall between these two perfect squares, 484, 529. But remember, it's not 512, it's the square root of 512. So our number is going to be somewhere between 22 and 23. Okay. So now what I have to do is estimate which one it's closer to. All right. So we can do two subtraction problems to see which one it's closer to. So we have 512 minus the 484. That's a 0. And we get 12 take away 4 is 8. I'm going to have to rename again. 10 take away 8 is 2. And then I'm going to subtract these two. And I get a difference of 17. So much closer to the 23. So when I start guessing, I'm going to guess a number closer to the 23. So I'm going to guess between 22 and 23, closer to the 23. I'm going to start with 22.5. And then this is what you end up doing. We talked about a way to estimate square roots. 25, 12, 11, placeholder, 10, 5, 4, 2 placeholders, 10, 5, 4. And there would be 2 digits after the decimal point. So that 506.25, pretty close to 512. Let's see if we can get closer. Let's try 22.6. 36, 12 and 3 is 15, 12 and 1 is 13, placeholder, 12, 5, 4, placeholder, placeholder, 12, 5, 4. 6, 7, let's see, I got 10, 11, oh my goodness. That can't be right. I did something wrong. What did I do wrong? Oh, I don't know where that 1 doesn't belong there. That's the 1. 2 digits after the decimal point. 510.76. That's pretty darn close. Looks like it's going to go up by another 6. So I'm going to say this is going to be my best estimate. So B, because I'm estimating it, I now have to use an approximate symbol, and I get 22.6. So when I write my answer, I would say the length of, now this is a leg, the leg is about, that means I'm approximating my answer, 22.6, and what's the label? Meters. Okay? So that's the Pythagorean theorem. It helps us figure out the missing part in a right triangle. But it also helps us determine if we have a right triangle. Okay? So That is called the converse of the Pythagorean theorem. So a converse is when you take and you rearrange the parts. Okay. So in this one, we're not told we have a right triangle. What we're told is we have 3 measurements for the sides of a triangle. Our job is to determine if it's a right triangle. Okay? So this is what it says. If the sides of a triangle have lengths A, B, and C, and, so we have 2 stipulations that need to be met, and that value of A squared plus B squared equals C squared, then, so here's our conclusion, the triangle is a right triangle. So if we're given 3 sides and we're told it's a triangle, we take those 3 sides and put them into Pythagorean theorem. And what's on the left equals what's on the right, then yes, we have a right triangle. But if what's on the left does not equal what's on the right, not a right triangle. Okay? So let's talk about A, B, C. What I would do is make A always your smallest length. I would make C your largest length. And B is the middle length. If you just remember, A, B, C is the order of the alphabet and therefore the order of the numbers. And then that will help you plug it into Pythagorean theorem. If you don't put them in order from least to greatest, then you're going to end up not being able to, you'll get no's when you should be getting yeses. Okay, so this is really important, that we're going to take our 3 numbers and put them in order from least to greatest. So let me write that in words. Write numbers in order from least to greatest. So that's the first thing you're going to do with your numbers. Okay, so the directions are going to change now, and they're going to say, given the lengths of 3 sides of a triangle, determine if it is a right triangle. Oh, sorry, triangle. So example 1 for this one is going to be the sides are 5 inches, 12 inches, 13 inches. So first thing I have to look at are my numbers. Are they in order from least to greatest? Yes. If they are, then I'm just going to assign them A, B, and C in that order. Okay, so these were done for us. So now I'm going to plug them into Pythagorean theorem, which remember says A squared plus B squared equals C squared. So what we're doing is asking, is the sum of A squared plus B squared actually the same thing as C squared? So let's put the numbers in and let's check it out. So 5 squared plus 12 squared, does that equal 13 squared? So what's 5 squared? 25. What's 12 squared? 144. What's 13 squared? What is it? 169. So let's add these guys here. And does 169 equal 169? This is true. Since this is true, then we say, yes, this forms a right triangle. Okay? All right, one more. What if I have 4 feet, 7 feet, 5 feet? Are those in order from least to greatest? Oh, no. So let's rearrange those in order from least to greatest. 4 feet, 5 feet, 7 feet. So now I can label them A, B, C. And now I can put them into Pythagorean theorem. A squared plus B squared, does that equal C squared? 4 squared plus 5 squared, does that equal 7 squared? What's 4 squared equal? 16. What's 5 squared? 25. What's 7 squared? 49. So we're going to add these, and I get 41. Ooh, does 41 equal 49? No. So we say, no, this is not a right triangle. It's not that it's not a triangle, it's just simply not a right triangle. We're told it comes from a triangle, but it's not a right triangle. So that's what you guys are going to be working on for your homework tonight.